Hello students, welcome to our student support program for mathematics grade 10 and grade 11. Our topic for today is simultaneous equations. This chapter has been divided into 3 parts. So let us have a look at our first lesson on simultaneous equations. The prior knowledge for this chapter is: you should know how to draw straight lines given their equations. You should be able to solve linear equations. You should know how to substitute values in an equation, how to change the subject of formula, and how to add and subtract algebraic terms. So the learning outcomes for this chapter are: what are simultaneous equations? The methods used to solve simultaneous equations. In today's lesson, we will look at elimination method, and in the second part, we will look at substitution method. In the last session, we will learn how to solve word problems involving simultaneous equations. And we will also work out some exercises for practice. So let us start. Let us have a look at simultaneous equations in our real life. Suppose you're given this problem. A cup of tea and a cup of coffee together costs 35 rupees. The total cost of 2 cups of tea and 3 cups of coffee is 90 rupees. And you're asked to find the cost of 1 cup of tea and the cost of 1 cup of coffee. So, do you have any idea how you're going to proceed to find the cost of 1 cup of tea and the cost of 1 cup of coffee? So this is an example of where we can apply simultaneous equations in our real life. So what are simultaneous equations? They are equations involving 2 or more algebraic equations which have the same variables. In our grade 10 and grade 11 syllabus, we are going to restrict ourselves to 2 equations involving 2 unknowns. So these equations will be called simultaneous equations because we are going to solve both equations at the same time. Some examples of simultaneous equations are 2a plus b equal to 10 and a plus b equal to 7. So you can see here we have 2 equations and our 2 unknowns are a and b. Second example, x plus y equal to 6 and x minus y equal to 2. So again we have 2 equations and 2 unknowns, that is x and y are our unknowns. Now let us consider the following pair of simultaneous equations. X plus y equal to 6 and minus 3x plus y equal to 2. So what does it mean to solve the following pair of simultaneous equations? It means that we are going to find the point of intersection of these 2 lines. In other words, solving a pair of simultaneous equations means finding the point of intersection of the 2 lines. Now, you will recall that to draw a straight line, we need at least 2 coordinates. Let us consider the first line. X plus y equal to 6. So if I take x equal to 0, I replace in the equation of the line x plus y equal to 6, I will get y equal to 6. So the coordinates will be 0, 6. If I take x equal to 2 and I replace in the equation of the line x plus y equal to 6, I will get 2 plus y equal to 6 and y will be equal to 4. So the coordinates will be 2, 4. In this case, I have decided to choose x equal to 0 and x equal to 2, but you can choose any other values. Now, let us consider the line minus 3x plus y equal to 2. So here I have chosen x equal to 0 and I replace in the line minus 3x plus y equal to 2. So if x equal to 0, I will get minus 3 times 0, which will give me 0, plus y equal to 2. So this means that y will be equal to 2. The coordinates will be 0, 2. The next value I have chosen is x equal to 1. And I replace in the equation of the line. So minus 3 times 1 will give me minus 3 plus y equal to 2. So y will be equal to 2 plus 3, that is 5. The coordinates will be 1, 5. So now we are going to plot the coordinates for both lines and we will draw the two lines. So for the line x plus y equal to 6, we will plot the coordinates 0, 6 and 2, 4. And for the line minus 3x plus y equal to 2, we will plot the coordinates 0, 2 and 1, 5. So after plotting the two coordinates for each line, we draw the two straight lines. So here we have a point 0, 6 and 2, 4. We draw the line x plus y equal to 6. And we also draw the line minus 3x plus y equal to 2 after plotting the points 0, 2 and 1, 5. Now we can see on the graph that the two lines intersect at the point 1, 5. The point of intersection is 1, 5. In other words, it means that x will be equal to 1 and y will be equal to 5. So this is also one method how we can proceed to solve simultaneous equations. So as mentioned earlier, we have different methods to solve simultaneous equations. We have the elimination method, the substitution method, the graphical method, which we have just seen, and the matrix method. In today's lesson, we will learn how to solve simultaneous equations using the elimination method. In the second lesson, we will learn how to solve simultaneous equations using substitution method. So what does elimination method mean? As the word elimination implies, it will mean eliminating one of the two variables. We will have to eliminate one of the two variables. Now, one small tip on how to proceed. If you want to eliminate, let us say, x, we need to check the sign in front of x. If we have the same sign in both equations for x, then we will subtract. If we have opposite sign, we will add. But before you add or subtract, you need to make sure that the coefficient of x in both equations are same. So let us have a look at some examples to better understand the elimination method. First example, solve a simultaneous equations x plus y equal to 9 and x plus 2y equal to 14. So let us have a look at the solution. The first step will be to write 1 next to the first equation and 2 next to the second equation. Now, I can see that the coefficient of x in the first equation is 1 and the coefficient of x in the second equation is also 1. So here we have same coefficient for x in both equations and we also have same sign. So when we have same sign, we subtract. So what we're going to do now is x minus x, which will give me 0, y minus 2y, which is going to give me minus y, and 9 minus 14, which is equal to minus 5. So I get minus y equal to minus 5. I divide by negative 1 on both sides, and I get y equal to 5. Now remember, in simultaneous equations we have two unknowns. So we have already obtained the value of y. We need to find the value of x. So I decide to substitute the value of y into equation 1. But you can also substitute the value of y into equation 2. So x plus y equal to 9 is my first equation. I will therefore have x plus 5 equal to 9 because I replace the value of y by 5. And I get x equal to 9 minus 5, which is 4. So for this pair of simultaneous equations, I will get as answer x equal to 4 and y equal to 5. Now we can check if our answers are correct. So how are we going to check? We are going to substitute the values of x and y into the other equation. Since I have already taken equation 1 here, now I will take equation 2. So the left-hand side in equation 2 is x plus 2y. I will replace x by 4 and y by 5. And this is going to give me 4 plus 2 times 5, which is 14. And this is equal to the right-hand side of the second equation. So it means that my answers are correct. Let us have a look at this second example. Solve the simultaneous equations x plus y equal to 8 and x minus y equal to 5. So here you can see that the coefficient of x in both equations will be 1 and the coefficients of y in both equations will be 1 as well. So we can decide whether we want to eliminate x or y. Remember, we need to label our two equations, equation 1 and equation 2 respectively. So here I have decided to eliminate y. I check the sign in front of y. In the first equation I have plus, in the second equation I have minus. Remember, we have already checked that the coefficients in both equations for y are equal to 1. So when we have opposite signs, we are going to add. Now x plus x will give me 2x. Y plus minus y will give me 0. 8 plus 5 will be 13. So we have 2x equal to 13. And x will be 13 over 2. Once we get the value for x, we now substitute the value of x to get the value of y. We can substitute in equation 1 or equation 2. Here I have chosen to substitute the value of x into equation 1. So 13 over 2 plus y is equal to 8. Y will be 8 minus 13 over 2, which will give me 3 over 2. Remember, you can always check your answers. So substituting values of x and y into equation 2. My left-hand side for equation 2 is x minus y. I replace x by 13 over 2 and y by 3 over 2, which is going to give me 10 over 2, that is 5, which is equal to the right-hand side. A third example now. Solve the simultaneous equations x plus 2y equal to 4 and minus x plus y equal to 8. So first we need to label our equations 1 and 2 respectively. We look at the coefficients for x. In both equations, the coefficient for x is 1. We look at the signs. Equation 1, we have a plus in front of x, but in equation 2 we have a minus sign. So when we have opposite signs, we need to add. So we will add equation 1 and 2. X plus minus x will cancel. 2y plus y is equal to 3y, and 4 plus 8 equal to 12. So y will be equal to 4. Now we substitute the value of y into equation 2. So I will get minus x plus 4, because y is equal to 4, equal to 8. Minus x will be equal to 8 minus 4, which is 4. And x will be equal to negative 4. Now we can check our answers. So I replace the values of x and y into equation 1. Left hand side of equation 1 is x plus 2y. I replace x by minus 4 and y by 4. So I get minus 4 plus 8, which is 4, and this is equal to the right hand side of equation 1. This means that our answers are correct. We now move on to the next example. So here we have 5x minus 2y equal to 16 and 3x plus 4y equal to 20. We can see that the coefficient of x is 5 in the first equation and the coefficient of x is 3 in the second equation. We do not have the same coefficient. For y in equation 1, the coefficient is 2, and in equation 2, the coefficient is 4. So again, we do not have the same coefficient. To be able to eliminate one of the variables, we need to have the same coefficient. So how are we going to proceed now to solve these two equations? The first step will be to label equation 1 and 2. Now, suppose I decide to eliminate the variable y. So I have to get the same coefficient for both equations for y. I decide to multiply equation 1 by 2 so that I will get 4y just as in equation 2. So multiplying equation 1 by 2 will give me 10x minus 4y equal to 32. And I have called it equation 3. Now I will work with equation 2 and equation 3. So you can see here that we have the same coefficient for y, but we have opposite sign. Do you still remember what to do when we have opposite signs? Yes, we need to add. So adding these two equations will give me 10x plus 3x, which is 13x, minus 4y plus 4y will give me 0. 32 plus 20 will give me 52. So 13x equal to 52. X will be equal to 52 over 13, which is 4. So what will be the next step now? Yes, we need to find the value of y. So we substitute the value of x into equation 2. 3x plus 4y equal to 20. So 3 times 4, 12, plus 4y equal to 20. And I will get 4y equal to 20 minus 12, which is 8. Y will be equal to 2. You can check if the answers are correct. So I substitute the values of x and y into equation 1. The left-hand side will be 5x minus 2y. I replace x by 4 and y by 2. So I get 20 minus 4, which is 16, which is equal to our right-hand side. So this means that x and y are correct. Now we move on to the last example. Solve the simultaneous equations 2a plus 3b equal to 12 and 3a minus 4b equal to 1. So the first step will be to label our equations as 1 and 2. Now let us have a look at the coefficient of a. In the first equation, the coefficient of a is 2. In the second equation, the coefficient of a is 3. They are not equal. I check for coefficient of b. In the first equation, the coefficient of b is 3. In the second equation, the coefficient of b is 4. Again, they are not equal. So now we need to decide which variable we want to eliminate. Suppose I decide to eliminate the variable b. This means that I will need to get the same coefficient for b. So I find the LCM of 3 and 4. The LCM of 3 and 4 is 12. So this means that I need to get 12b in both equations. Now, how will I get 12b in equation 1? It means that I will have to multiply equation 1 by 4 and equation 2 by 3 to get 12b. So each term in equation 1 will be multiplied by 4 and each term in equation 2 will be multiplied by 3. I will therefore obtain 8a plus 12b equal to 48, multiplying equation 1 by 4, and I call it equation 3. Now I multiply equation 2 by 3. I get 9a minus 12b equal to 3. And I call it equation 4. So here we have the same coefficient for b, but we have opposite signs. And when we have opposite signs, we need to add. So adding equations 3 and 4 now, 8a plus 9a will give me 17a. 12b plus minus 12b will cancel. 48 plus 3, 51. So 17a equal to 51. A will be equal to 51 over 17, which is 3. Now we need to find the value of b. So we substitute the value of a into equation 1. I have chosen equation 1 here, but you could have chosen equation 2 or even 3 or 4. So 2 times 3 plus 3b equal to 12. 3b will be equal to 6 and b will be equal to 6 over 3, that is 2. Remember, the last step would be to check your answers. So I will replace the values of a and b into equation 2. The left-hand side will be 3a minus 4b, which will be 3 times 3 minus 4 times 2. 9 minus 8, which will be equal to 1. And this is equal to our right-hand side. So this means that our answers are correct. Now, I'll give you some exercises to practice on elimination method. So you will have to solve all these equations using the elimination method. So students, in today's lesson, we have learned what are simultaneous equations and how to solve simultaneous equations using the elimination method. We will stop here for this lesson. Until we meet again, it's goodbye.